Say when we started 6.3, we were introducing logarithms, right? We spent a big portion of the day with logarithms going back and forth between log form and exponential form, using that left, right, middle. So we're still going to use that, and we'll use that some possibly when we solve equations down here in the next section, but we're going to get the easy part out of the way. We're going to talk the calculator part here. So I mentioned yesterday that the normal base of a log is log 10. Okay, so if you have, when you have a log button on your calculator that just says log, it is base 10. Okay, so base 10 logarithm is called the common log and can be written as log of x with the base of 10 implied. So if you see a log with the log, no base written here, just log of x, we automatically know that it is base 10. Okay, that's the invisible base. All other bases would be written in. So that is what we call common log, base 10, and that's what your log button on your calculator does. We also have something called the natural log. And natural log is base e. If you recall, we talked about e last week being the natural number. It's that 2.718 number. Maybe it was this week, whichever, we talked about it. But base e is called, the base e log is called the natural logarithm. And it is written as natural log, or ln(x). So on your calculator, you're going to have two buttons somewhere. You're going to have an log button, which is the log base 10 button. And you're going to have an ln button, which stands for natural log. Okay? And that is an automatic base e. So you rarely see natural log base e written. It's usually just written as ln(x). So when you see those things, we know that that's the base that is implied. Okay? Now, this section is the fun and easy section. Use a calculator, okay, to find the value of each logarithmic expression to the nearest 10,000. So we'll have to talk about the rounding there. So, log of 900. Have you tried it? And as long as you're using a scientific calculator, everyone has a log button somewhere, right? What'd you get, Patrick?
2.95.
Okay, I need more decimal places than that, but yes.
2.95.
Okay, let's talk about how many decimal places we need here. 10,000ths. Tenths, hundredths, thousands, 10,000. So I need 4. So 2.9542. Did we all find that and get that on our calculator? Do I need to demonstrate that? I'm guessing you can all hit a log button and type in the number, right? Okay. So I know on my calculator it probably brings up automatic parentheses. You can end the parentheses. You cannot if you're not doing anything else. Okay. What about B? ln, natural log of 1,215. What do you got, Jayden?
7.1025.
Yep. 7.1025. Again, 10,000ths, so that is 4 decimal places. Okay. C. Natural log of negative 1.87. Okay, you're getting an error of some sort. Okay, some calculators, the TIs say domain error. I don't know what Casio's or some of the others say, but you're getting some kind of error. Why are we getting an error? We talked about why yesterday. Yeah, the number inside here has to be greater than 0. It can't be negative, it can't be 0. So, do you remember what we put yesterday? Yeah, it's undefined. And that's because you can't take a log of a negative number, okay? You're going to get some kind of error. Domain error is saying that a negative value is not in the domain of this function. That's why they're calling it a domain error for you, okay? Okay, log of 321. 2.5066. What comes after?
5.
Okay. I say I have 2.5065. I guess, are you guys checking the rounding? Because that's the only thing I'm not talking about by not demonstrating them on the screen. Are you getting the rounding okay? Remember, look at that fourth digit. See what the fifth digit tells it to do. Okay. I don't know, do I need to demonstrate this one? Okay. Now, I'm trying to think on my calculator. You guys are figuring it out, right? ln of e. Are these calculators, is there just an e or is there only e to the x? So what do you need to put in for that x? It's going to be e to the first, right? Okay, because I don't think I'll let you do it without putting anything in there, will it? I'm going off of total guessing here. But I don't think I'll let you do it without filling it in. So, okay. So, natural log, if they want natural log of e, mine is second e right there. As I said, yeah, syntax error means it doesn't like what I've entered. So then I'm going to have to put a 1. Because if you have an invisible exponent of 1, you can in parentheses, you cannot. What is the natural log of e? All of that inserts, all of that work to get 1. Now, this relates to an upcoming property I mentioned yesterday. What is this base here? There's an invisible base e, yes? What's the exponent here? 1. Do you guys remember I pointed out that when the base of the log and the base of the inside are the same, it's going to be equal to the exponent? That's exactly what's happening there. I'm not saying you need to recognize that now. I haven't even taught that property, but looking ahead to upcoming things. Okay, and f, log of 1700ths. What are we getting? I heard part of it. I couldn't hear it all. Negative 0.7, then what was after that?
696.
Okay, 696. Okay. Okay, questions on the calculator? Easiest part of the lesson, right? Okay, it's basically push the log button and go from there. Now, keep the calculators handy because we're still going to need them when solving equations, okay? So what we did yesterday, we weren't using the calculators. What we're doing today, we are. We're going to talk today about how to solve equations that have logs in them or exponents. It depends on the situation here, okay? And the directions are round to nearest 10,000. When you see round to nearest 10,000, you know that's a decimal type problem. So, on A, log of x minus 3 equals negative 1. Our job, of course, is to solve for x. Any thoughts? What'd you say? Okay, you cannot add that 3. Okay, so that's, you know, things I need to answer, right? We're guessing at this point because you guys don't know what we're doing. But that log of x minus 3, that x minus 3 is one quantity that is currently stuck inside that log. Okay, we can't do anything right now because it's the insides of the log. And if it's stuck inside the log, we can't do anything with it right now. Do we know a way to get this out of logs? What? No. And again, that goes along with that x minus 3 is stuck with that log right now. We can't use our normal basic operations of add, subtract, multiply, divide to separate pieces of that log. Huh?
Log x minus 3.
Well, you don't have a number for x, though. What did we learn yesterday to get something out of log form into another form? What?
Left, right, middle.
Left, right, middle. Could we use left, right, middle here? Left, right, middle. Now, with that, when we say left, right, middle, what do we have to know about this log? What base is this log? Okay, there's no log written in, so we assume it is implied that this is base 10. There's an invisible 10 there. So, when we learned left, right, middle yesterday, what's left, right, middle say? The left of 10, then what? Raised to the right of -1 is going to equal the middle of x minus 3. Have we forgotten all that since yesterday? Okay, left, right, middle. So remember to go out of log form into exponential form. We can use that left, right, middle. So base of 10. So the left to the right equals the middle. Now do we have an equation we can solve? Yeah? What do you know about 10 to the negative first? Okay, it's 1 over 10, yes. Because to make that exponent positive, it's 1 over 10. Some of you used your calculators, didn't you? What is 10 to the negative first according to your calculator? 0.1, which is 1/10, yes? So whether you have a decimal or a fraction at this point, I don't care. Okay, how do we solve for x? Okay, now I will let you add 3. Okay, since it's x minus 3, we're going to add 3. And with that in mind, what is 1/10 plus 3? Okay, 3 and 1/10 or 3.1. And I know my brain goes to 3 and 1/10, but Savas wouldn't want 3 and 1/10 as a mixed number. They would want 3.1. Or maybe they'd want it improper. I'm not sure. So, yes. This is an emergency.
Yeah.
Do you have your passbook? That's the winner from yesterday. When you ask me to go to the restroom, guys, you gotta say yes to the passbook question. Okay. Questions on A? Okay. Can we carry that process over to B? Natural log of 2x plus 3 equals 4. What are we going to do? Left, right, middle again? Now, before we start, what do we need to remember here? Okay, the invisible base on natural log is e. Okay, with that being e, that is your left. Okay, so left, right, middle reads as, someone read it for me. E to the 4th equals 2x plus 3. The e is the left value, raised to the 4 on the right equals the middle of the 2x plus 3. Now, what do we know about e to the 4th? It's going to be some lovely decimal, yes? That's going to be a calculator thing. So here's what I'm going to do. In the end, yes, I'm going to have to figure out e to the 4th. Okay, my calculator's going to do that. For right now, because I don't want to write a big, long, messy decimal, I'm going to leave it as e to the 4th on my paper or on my screen. How do I solve for x? Subtract 3, yes. Since it's 2x plus 3, we're going to subtract 3. So then as I write that out, I have e to the 4th minus 3 equals 2x. And then how do I solve for x? Divide by 2. Now at this point, we know 2x divided by 2 is going to become x. This becomes calculator problem. Okay? E to the 4th minus 3, and then all divided by 2. Now, there's times I've been pushy about the calculators. I'm going to go back to being my pushy self because there are right ways to enter this in the calculator and there are wrong ways to enter this in the calculator. So take a moment and try something, and let's see if we all get the same answer. Because I'm guessing we won't all get the same answer. There's the right answer up on the TV screen to match up with. If you got that, great. If you didn't, let's talk about how we use the calculator. Because as I said, there's right ways and wrong ways to use the calculator. And that's plural. There's not just one right way to enter the calculator. What I'm going to say, if you got a wrong answer in your calculator, whatever. Okay? If you have like a Casio or whatever where you guys can put a fraction marker in, you should be okay. On the Texas Instruments, either do it in pieces, e to the fourth equals, so hit enter, minus 3 equals, hit enter, divided by 2 equals. Okay? So like hit enter after each step, or if you want to do it all at once, here's what I'm going to say. You need to think about this e to the fourth minus 3 in parentheses. Okay? And this comes down to know how to use your calculator, right? Before test time, know which way is what does my calculator do and not do. So like I could have done e to the fourth equals minus 3 equals divide by 2 equals. Okay. The other option is if you saw me originally, I just start off with parentheses around my numerator. So parentheses, e to the fourth, I'm ending the parentheses after the 4, minus 3, and now I'm ending the parentheses on top of my fraction, and then divide by 2. You got something that works? Let's see, what are we doing? 10 thousandths again? So 4 decimal places, what are you giving me? 25 point 7991. Everyone went silent on me. Okay, so when you have the e's, you're going to have some decimals involved, definitely. Not that some of the others wouldn't, but you'll definitely have some decimals. Okay, let's talk C. Log of 3x minus 2 equals 2. What's our first step here? What? Left, right, middle. And our left is what? Invisible 10, because it says log. That's a common log. So left, right, middle is going to read 10 to the second equals 3x minus 2. Okay? Left, right, middle. Do some math. Some of you are ahead of me, I think. What is 10 squared? 10 squared is 100. How do I solve for x? Okay. If it's 3x minus 2, we're going to add the 2. And then 100 plus 2 is 102 equals 3x. And divide by 3. What is 102 divided by 3? 34. Okay. You got the idea on the top row. Okay, they're log equations. Think left, right, middle to get out of them. Okay, think left, right, middle to get out of them. Now, bottom row. Looks a little different, doesn't it? We don't have any logs, but I don't know if I want to say problem, okay, The concern is that we're trying to solve exponential equations. We have to have a way to solve when our variable is in the exponent. Okay? And this isn't something where a guess and check is going to work, especially when it's e to some power and we're trying to equal 8. Guess and check isn't going to work. Thoughts here? What do you mean?
I don't think, I mean, we just have to come tell me stuff.
Okay. I was just trying to figure out if there's a different way I could be going here that I wasn't seeing. I don't see a way to make it a fraction. What were we using in the top row? We were using left, right, middle. And we were using left, right, middle to go out of log form into exponent form. What if we go the other way around now? Okay. And I can't say it will always work, but the way these are set up, it should work. Okay. So first of all, I am going to say before you do this, make sure that your power is by itself. So e to the x plus 2, I don't have other pieces being added or subtracted or multiplied or divided with this power. But go into log form here. If we're going into log form, okay, you can think left, right, middle, right? Or the way I kind of think about it is my base stays the same. So the base of the exponent is now the base of my log. I'll have to deal with that issue in a moment. So I'm going to write log base e, and then what happens with the x plus 2 and the 8? They're going to switch, right? So this is log base e of 8 equals x plus 2. You can also think left, right, middle there. It's just we're taking it out of exponential form into log form. And so the e on the left, the 8 from the right, and it equals the x plus 2 in the middle. Now, in my mind, that's kind of weird. It doesn't necessarily look weird to you guys, but log base e of 8. Okay, log base e really should be written as ln. So this is really natural log of 8 equals x plus 2. In technicality, can you write log base e? You can. It's not our traditional, I know, but you can. Okay, now, natural log of 8. That's going to be some decimal my calculator is going to provide me here in a moment, isn't it? Again, I don't want to have to write the decimal parts. So, how do we solve for x? We're going to subtract 2. Okay, good old traditional solving. And so, when we solve this, I'm going to go ahead and flip my sides. I'm going to have x equals the natural log of 8 minus 2. It's a calculator problem, yes? Not as many ways to make mistakes, but there is a mistake that can be made. Does your answer match my answer? Okay. Now, the thing to watch out for is natural log of 8 minus 2 the same thing as natural log of 6? No. Okay, so you'll notice on my calculator, I did natural log of 8 in my parentheses and then minus 2. This is not subtracting from the inside of the log. Okay, I can't say, oh, well, this is just natural log of 6. It's subtracting from the natural log of 8 quantity. Okay, what is this answer? What are you going to write down in your paper? 0.0794. 794 10,000ths. Okay. Notice, when we did this today, we got a log button on the calculator, didn't we? Okay. And the problems you're doing today, when we undo and go back to log form, we're going to get log buttons on the calculator. So they're either going to be log base E, which is natural log, or log base 10, which is the log button. Okay, E. Yeah.
Isn't it log 25 equals x
I think that is the flipped version, but. Or you mean you have to flip it here? I'm not sure which. Okay, so, and what I'm going to say, because I'll be honest, I was pausing in my brain to think, okay, is that right or is that not right? My brain sees it better as, okay, this is, and again, not everyone needs to do this. Okay, 10 to the x minus 1 equals 25. Okay, if you need to do that flip, right? But if we're going into log, this is going to be what? Log base 10 of 25 equals the x minus 1. Okay, so whether you write down that first flip is up to you. Now, I wrote log base 10 of 25 because I did. Okay, because I'm trying to show you where does this 10 go. This is my left, my right, my middle. Log base 10 of 25 could also just be written as log of 25. Okay, you don't have to write the 10 there. How do we solve for x? It's x minus 1. We're going to add 1. And so in order to get this answer, I'm going to be doing the log of 25 plus 1. Or you could write it as 1 plus the log of 25, couldn't you? Is this the log of 26? Nope. So, check your calculator. We've all practiced with them today, right? Getting comfortable with these log buttons? Log of 25 plus 1. What do we have? 2.3979. Okay. One more here, and that is F. 1.5 e to the t equals 27. Thoughts on where to start here? Maybe I should ask what's different about this problem. Well, it's t instead of x. Is that going to make much of a difference? No. Yeah, there's something attached to the e to the t. Okay. Here's the deal. We can't do a left, right, middle right now. You can't do a left, right, middle until you have something raised to a power. So just 10 to the x minus 1 or e to the x plus 2. It was one base raised to a power. What's my base raised to a power here? E to the t, yes? Is that 1.5 part of that? No. So before we get started, how can I move that 1.5? Not subtract it, but divide it. Since it's 1.5 times e to the t, let's divide. So at that point, 1.5's cancel. I have e to the t. Does 27 divide nicely by 1.5?
Yes.
It does. What is it? 18. I'll be honest, if it was going to be a big, ugly, messy decimal, I was just going to leave it written as is. Now, e to the t equals 8. Now what do? I have a base raised to a power. So, how do we go to log form? Left, right, middle. So this is going to be what? Log base. My e is my base here, so that's going to be my base of the log. So log base e can also be written as natural log, yes? So that's going to be natural log. I'll put the e there just for reference. But natural log of e, so the base on the left, the 18 from the right equals the t from the middle, the exponent. So we end up with natural log base e of 18 equals t, but natural log is base e. So what do you need to do? Natural log of 18. What's my calculator answer? Okay, 2.8904. Okay, got an idea of how to solve equations here? Okay, so that takes us to the end of 6.3.